2.
What time do I end there, John? That way he gets me on my
We're going to hurry all the way through. Everybody's got to help though the whole time.
Alright.
So we have this. What's the rule? When you look it up in your notes, what's the rule? It says
Negative 1.
AB to negative BA.
AB
To negative BA.
to negative BA. Now, where a lot of people's having trouble with this, is you got to do two things. So this first point right here, negative 11.5.
Gotta switch it.
What's that going to be?
Negative
It's
5.
like 11.
And you see how Coltney had trouble because you start to do one thing, then what might be helpful, do it one part at a time. If I have this, I know I got to switch it, right? So maybe before we do all of it, just switch the order. 5, negative 11. All right? Then once you switch it, then look up here. What's it tell us to do to this first? It tells us the opposite. So negative 5, negative 11.
Every
Now-
single number should have been negative.
Wait, what? Is that right?
No, that's not right. That's not right. No.
Yeah.
That's not right? This isn't the right rule?
That's the right rule up there, but the 11 should be positive, shouldn't it?
No, the whole shape should have been in the bottom left corner.
No.
No,
Yeah.
because just
Good
see
job,
how the
Courtney.
A is still, it had the sign,
There
and you don't
goes
change
his
anything
A.
about it.
Yeah.
Now you understand it though, right, Lane?
Yeah, but now I get a bad grade for it, so.
You'll be alright. It doesn't count that much. So that's the whole purpose of this quiz, because this quiz doesn't count a whole lot. So on the test,
Yeah, but it's still gonna drop my grade a whole.
Make it very chill again.
how about B prime? B prime, if we switch it around, I didn't want to write it there. We switch it around, we got 2, negative 6. What do we got to do to that 2?
Negative.
So negative 2, negative 6. How about C prime? Just give me that real quick.
Negative 4, negative 3.
Everybody agree with Quentin on that one? Now if I graph that, 1, 2, 3, 4, 5, 11. 11's actually going to go off my slide here. That's A prime. Negative 2, negative 6 is right there.
Winner.
B prime. Negative 4, negative 3. C prime. Connect them. What should happen? It should be the same shape. If I came up with a shape that looked like this, then what do I know?
Yeah, you're wrong.
I probably counted wrong somewhere. Go back and fix it. Alright? So that's what it should look like. That's going to be where your points come from. Open up your books to page 194. 194.
There goes back.
On 194. My last class, they had to turn this in. We don't need to do that in here, do we?
No.
I made them write down all these problems I'm getting ready to do up here because they were not helping, not participating and stuff. So I said, all right, write down everything and you're going to turn it in. We don't need that, right, Daniel?
No.
So you're going to participate, right?
Which class was this?
My last one.
Marshall ran
So
out now.
intervention.
B3A or B3?
So on this, 30 degrees counterclockwise. First thing, counterclockwise, I always have to do this. I know Mackenzie doesn't need to do it because that's just, she's that intelligent. But I have to put the arrow showing me which direction counterclockwise is before I start anything else. 30 degrees. When we go to do a problem like this on the test, and the test will be probably next week, early next week. When we go to do a problem like this on the test, I'm not going to expect that you can be exact. There's going to be 3 things I'm going to look for when you're doing a problem like this one. What do you think I'm going to look for?
Like distance from.
All right, so let's say the amount of turn, all right,
Same shape.
Yeah.
same shape, should look the same. What else?
Around P.
Going the right direction.
Direction. Those are the three things I'm gonna look for. Did you turn it counterclockwise? Did you rotate it about 30 degrees? Does it look the same as it started out as it looking? So if Dakota put his shape and it ended up like this, in that spot right there, would he get any of those points? No, because number one, he's got a rectangle down. We started with a triangle, so that doesn't look anything like the original. Number two, does it look like he turned it 30 degrees? Now it looks like a whole lot more than 30 degrees. And number three, well, I might give him 1 point because did he go the right direction? Yeah, maybe. I'd probably say, nah, I think you went this direction, so I could just mark all 3 points wrong. Since he didn't even have a triangle down there. So if we wanted to do this, this is all we're going to do. And if you're watching this, if you were doing it on a piece of paper, you're just going to estimate like this, and you should be able to get fairly close. Now, if you get a job, don't go in. Tabitha gets a job and she's doing something like this where she's got to map something onto something else, and she goes, well, my geometry teacher said that I could just estimate all this stuff. Probably not once you get something to where it's important, right? But here, I'm not that concerned about it. So I'm going to do this. I'm going to shoot shoot C right down here at P. We want it to come off at a 30-degree angle. Well, if you don't know what 30 degrees is, which I really don't know what it is, so I come over here. What's the measure of that angle? Looks like about 90. So cut it in half, it's 45, so that'd be like right there, right?
2/3 of that.
So we want something that look like about a 30-degree angle. Something about like that. So we want to bounce it off about that way. I bounce it off there. Let's see. Does that look like about 30 degrees?
Yep.
Now, this is all I'm going to do. If you're on your paper, you could do this with your fingers and get a little more precise. I'm going to do it this way. From C to P is about that far. So when I put C prime up here, it should be the same distance. Does that look like about where it should be? Spectacular. Right? Are we going to be exact? No. Tyler's looking at going right now going, Ebersol ain't going to be nowhere close. His shape's not, it's going to look like a circle or something stupid. So we do the same thing for B. We want to bounce B off of P down here. If I could hit it. Take me about 6 times. Going to bounce it off, 30 degrees. And I got a little wide there. There towards the end. Somewhere about like that. Measure this. Spectacular. B prime. A's a little easier. Bounce A off of it. It's going to come up this way, about 30 degrees. My pen quit writing. About 30 degrees. I can do it with my fingers. A prime will be somewhere about right there. What am I going to do with all 3 of those points once I have them? Connect them. That triangle look about the same as the original triangle? Does it look like I turned it 30 degrees counterclockwise?
Yeah.
Did I go the correct direction counterclockwise? Yeah. So, got a picture of that, Colton, in your mind? Keep that in your mind because I'm going to erase all that, and I actually did it out using the computer. See if I did it right. See if my other one was pretty close to where it comes out to be. We're going to turn it about 30 degrees. What's that point going to be labeled? C prime, thank you. C prime. My C was off, is that what you said? What's that point going to be labeled? B prime. A prime there. Connect connect them. Is that about where my shape was? Now, if you think about it, if we took a string and we tied a string right to the center of this triangle, if we found the center of it, we tied that string right to it and rotated it around this, would it look like that at a 30-degree turn? Yeah. Could we get some idea what it's going to look like way over here somewhere? Yeah. Probably, it's probably going to look maybe something like that. Would that be pretty close, just if we turned it all the way from here around to there? Yeah. And you could figure that out. Get it in your mind. Use your paper. Turn your paper. Mackenzie's up here drawing on my graph paper all the time. She wants to rotate this 90 degrees counterclockwise. Turn your paper and look at it and see, hey, that's where it should be. Lane was throwing a fit about his quiz. Could he have turned his paper before? Could he have graphed the original triangle and then turned it 90 degrees
Yep.
and said, oh, it should end up all down here in this bottom corner? Do that. Before you start to do it, do that.
I mean, you did that like in 4th grade.
Right. Next one, what's different about this one? What are we rotating it about?
150.
Points.
What are we rotating it about?
About one of its corners.
About one of its corners. So when I do this, and this is what I would do, because I hate this stuff. I don't like rotations, reflections, all that stuff. It confuses crap out of me. I'd much rather deal with numbers and everything than shapes. So I do something like this. I take that, and I just imagine that that shape right there is that four-sided figure that they gave me, and they want us to rotate it 150 degrees counterclockwise. Which way is counterclockwise? That direction, right? So we're going to turn it this way. Tell me to stop when we get to 150 degrees.
Keep going, keep going, keep going. You're right there.
About there?
No.
Maybe flat.
I think that's about right. All right? So something about there, what didn't move? The P didn't move. It's going to stay right where it's at the whole time. All right? So that's what, so now do I have some idea where I should be at?
Yep.
Yeah. So now I go do it, and my shape ends up here somewhere. What do I know? Hey, I messed up somewhere. All right, so I'm going to do this very, very quickly. First of all, 150 degrees. Instead of drawing a right angle, if I draw a straight angle, how many degrees is it? How many degrees is that? 180. Cut a little bit of that off. Is that going to be about 150 degrees?
Looks more like 160, but
You think it's a little too much? All right, we'll cut a little more off.
there you go.
Something about like that?
There you go.
That's 145.
That's too much.
That's
Good.
So if I do this, watch. I hit it here. It's going to bounce off this. We're going counterclockwise. So we're going this direction. About 150. Does that look like about a 150 degree angle?
Yeah.
Yeah, close enough. Measure it with my fingers. G prime. Going to end up somewhere about in there. Got my prime. Do the same thing for J. Hit it. It's going to go this way 150 degrees. Maybe something about in there. Got that distance. J prime is going to end up somewhere about in there. Colton back there is amazed that Eversole's just doing all this and it's coming out. He's thinking, man, there's no way it can come out. And then he does it, and the shape comes out to look exactly like the first one. This is not a rectangle. Is that where we said it should be? Does that look about right?
Yep.
Look about the same?
Yep.
If I gave you all the points, all right, Quentin, so it doesn't look quite the same. If I was gonna give points on this, did you turn it the right direction?
Yep.
Yeah, it looks like it. Is it about in the right location and everything?
Yes.
Does it look about the same? No, not really.
No.
Mine's a little off, so
You failed.
Would you still get that?
I'd get 2 out of 3. I'd probably give you the points unless your name's Colton. Then I didn't say you did anything. I just don't like people named Colton.
Nate's just.
Rotate 180 degrees counterclockwise about the origin. Somebody look up the rule, help me out, what's the rule say? What do you do to AB? 180 degrees counterclockwise.
AB equal, goes to negative A, negative B.
So all we do is change
Are we gonna be able to use our?
all the signs. I don't know, I might get
It's hard to
upset and make you
remember.
memorize. So we do that, alright? Do I even really need to do this one? What's gonna happen to this if we rotate it 180 degrees and our center is the origin?
It'll be in
It literally should be flipped.
Is it gonna move like way out here somewhere?
No.
Way over here?
No.
It's just gonna go, it's just gonna spin right around there and it's gonna look something like that maybe? Alright, it's just gonna spin around here.
Exactly like
Almost
that.
exact.
Because I'm
Side dude.
that much of an artist. What's different about this one?
Oh, why'd you go?
You
for
have-
this one?
I don't know, I just skipped through it for some of
We
them.
didn't have 12.
Oh, you didn't really?
Yeah, we had 11.
No, I must have liked it.
It looks like 11.
Yeah, we have Olivia.
Yeah, that is a.
What's different about this one? Instead of just doing one thing, what are we doing?
Got 2 things to do.
It's a composition, thank you, it's a composition. We rotate it 180 degrees clockwise. Watch on this one, because even Mackenzie with all her great artwork probably is confused. When I rotate this 180 degrees counterclockwise, is it going to end up like that?
No.
Because we're rotating about what? The origin. So what's going to happen is it starts like this. See if I can do this. Probably can't. Starting like that. And this is, my fingers are like a string, and it's going to turn,
Wait, so are they gonna be like parallel?
and it's going to end up being right there. Does that make sense? All right, that confuses the heck out of me every time I have to stop and think about it, because I think, man, that doesn't look right.
Yeah, I got that one.
But that's where it's at. All right. Once we have it there, so it's going to end up something like right in here. Oops, that's way long.
Maybe because I do.
It's going to end up there. Then what's this tell us? What kind of transformation is that?
Negative.
Reflection.
Not a reflection. It's a slide. It's a translation, right? That's a translation. So that's telling us to take this shape, and how are we going to slide it? What's that tell us? Down.
Down.
No, not down. I'm sorry, not down.
Left one.
Left one.
Up.
And up one. So it's going to end up sort of in the same spot, just out there a little farther.
Maybe it was.
What do we do when we want to reflect in the x-axis? How do we do that?
Reflector on
You count.
You just count. So this one is how many spaces from the x-axis?
4.
4. So what's it going to end up in?
4.
Down here, 4. This one's how far? So it's going to end up down there 2. This one is 6. So it's down 1, 2, 3, 4, 5, 6. Now, if Teresa counts wrong and she graphs it and looks at this, is her shape going to look the same?
Oops, you got it.
No. So then she's going to think, she's going to look at it and think, that doesn't look the same. Did I do something wrong? Go back and recount it and fix it. Should be easy. All you're doing is counting. What if we wanted to then take that and rotate it 270 degrees counterclockwise? So if we're going counterclockwise, that's this way. If I turned it to right in here, how many degrees would that be?
90.
90? How about right to about here?
180.
180? How about to right here? 270. That's 270. Alright? So when we're done here, this shape should end up over in this area right here. What's an easier way? Instead of going 270 degrees counter, we could have done 90 degrees clockwise and been the same thing, and that's what your rules tell you, right? That they're the same. Watch closely on these, just to make sure everybody understands these. Because these are easy. Quentin should be able to get every one of these. If I put these on the test, you should be able to get every one of these right, because these are easy problems. Alright? If I put a dot right here in the middle, we're going to rotate that about that. The first thing I would do anytime I'm dealing with rotational symmetry is I would find the order. Now the order, what the order is if I take this take this book right here, and I rotate it about some point right through the center, one whole turn, we want to know how many times it looks exactly the same as what it started. Alright? Is this one going to be 4?
No.
So that's two.
That's 1, right?
Oh, it's just
2. So what's the order of rotational symmetry on this book? 2. What's the order of rotational symmetry on this?
4.
That's 4. This book doesn't want you to know that number for whatever reason, but I want you to be able to figure out that number. Because what we can do with that then is figure out how much of a turn it takes to get this point up there to where it looks exactly the same.
Divided by 360.
So you take that and you divide it into 360. Well, this one's pretty easy because how much of a turn? 90 degrees. Now what if I wanted to get this point up to there? Turn it 180. So what we're saying on each of those, this shape has rotational symmetry at 90 degrees and at 180. Now it would also have rotational symmetry at 270, but what I tell you last time, don't go past.
So should we just say every 90 degrees or should we?
No, you should write both those out. They're both separate answers. It's got rotational symmetry at 90 degrees. It's got rotational symmetry at 180 degrees. Now this one's a little harder, and this will show you how to do all this. What's the rotational symmetry on this? 5. The order of rotational symmetry is 5. We take that 5, divide it into 360. How many 5s are there in 36?
72.
7, 35. How many 5s in 10? 2. So if I turn it so that this point right here ends up right there, how many degrees did I turn it? 72 degrees. Once I have that, it's got rotational symmetry at 72 degrees. Well, if I turn it so that this point's right up top there, how would I find out how much of a turn that is?
72 times
72 times 2, or 70, or what Colton started to say, add 72. 72 plus 72, same thing, right? What is it? 144. What if I wanted to get this point right around there?
It'd be too much.
It's too much. It's more than 180. So those are our 2 answers. What would the order of rotational symmetry be on this? What number? 3? What's 360 divided by 3? 120. So when I turn this so that this point is right up here, how many degrees did I turn it? 120 degrees. What's the 2 answers on this one going to be? 90 and 180. Notice the answers for this one's the same as the arrow one on the other page, right? Because what was the order of rotational symmetry on the arrow one? What was the order of rotational symmetry? 4. What's the order here? 4. What was the order on the star? What's the order on this pentagon? 5 also. Do we have to refigure out these every time we get some new shape? No. So if I gave you some shape that was like this, if I could draw, which I can't very well. If I give you some shape like that, and that's all supposed to be balanced out, what's the order of rotational symmetry going to be? 5. It's going to be the same as this one. All right? Last thing. This is going to be very, very important here in a couple days when we do the last section in this chapter. And when we get to next chapter, it's going to be very important. When we were talking about parallel lines, and I smashed these parallel lines together, the angles that matched up were called what kind of angles? Corresponding angles. It's the same thing here, and this is part of what we're going to do today. What would I have to do to get this shape to match up perfectly to that shape? Slide it right over there on top of it. And if I did that, angle A, make sure you're using your symbols. A lot of you getting stuff marked wrong on some of these little short quizzes that we're doing because you're not using your symbols. Angle A is going to match up to what angle?
Can you just put angle A, or do you need to put angle
Now, can we just write this angle A, or do we need 3 letters? If I say angle A, which angle are we dealing with? That's the only one, right? Normally, we'd want to name it with 3 letters, right? But do we have to in this case? No. What would it be if we wanted to name it with 3 letters?
BAD.
Angle BAD would work. What angle does it match up to? Now, let's do this. Segment DC. If I told you the length of this segment right here, DC was 12. Tell me another segment that you know the length of. The other one that it's going to match up to down there, LM. That's all we're doing. Are there a whole bunch of other angles and segments that match up in those 2 shapes? But we're not going to do them all because I want to move on. All right, go ahead and start copying these down. This is your notes for today. Somebody help Michael out, wake him up. Quick, I'll give you a quarter if you stick
That was my favorite thing to do.
Start writing this down.
This will wake you up, Michael. Look.
I wasn't even.
Michael, this will wake you up. I voted today.
You were snoring, man.
Michael, you were snoring so loud that you started your shroud tender.
That was a terrible analogy.
What?
That was a terrible analogy.
Why?
Just once.
Like 6,000.
Whoever said
It's
that.
going up.
you
It's
might
going up.
say,
Oh, it's going up
that
every
you
second.
can do a
What did I say
shot
earlier?
from
Quit worrying about it. Do this.
like,
you should enter
away.
Every time I look in your eyes and you're worried about that quiz, I'll make at least 2 points more.
Being happy, mine's a 25.
Are you gonna go after your?
What? I graded his 25. How? Homework. Teresa. I have 4 zeros.
Lane, you will be fine.
Alright.
Don't miss any homework.
I haven't. I missed this quarter.
Do you take gifts?
So make sure.
Did she just say that?
Monetary.
Do you really? It's like, I got a pumpkin.
Is that monetary?
It's just-
See, somebody needs to listen
I'll take
more
it.
to English class.
No, it's not for you, it's for Mr. Eversole.
Monetary.
Money.
Take the pumpkin.
Eat the pumpkin.
And Greek
Yeah, you can eat the pumpkin.
Make a pumpkin pie. Get into it.
What's one thing you guys can
There you
be
go.
surprised by?
And put a face in it.
Lane playing Jude.
I wanted to give him a pumpkin.
to talk.
Because I could. I saw a pumpkin, I was like, hey,
Do you
please
have one
like that
going
pumpkin.
Trina, why are you bad mouthing somebody for giving me something?
Linda's
Relax.
getting a varsity badge.
She's jealous because she didn't get a pumpkin.
She didn't get the pumpkin.
All right, what we're going to cover, congruency transformations. All a congruency transformation is when you transform a shape. So you slide it, you reflect it, you rotate it. All right? And you match it up to some other shape so that it's perfectly congruent to it, or so that it matches up perfectly. What's this symbol mean again? Congruent. So we're going to have to identify congruent figures.
Isn't that easy?
Yeah, it's pretty easy. You just match them up. Be able to describe congruency transformations. What'd you guys tell me I had to do to that 4-sided figure to get it to match up with the other 4-sided figure on the last slide? You were sliding it to the right. Now we're going to be a little more precise than that. We're going to say we have to slide it 8 units to the right or something like that. Give a rule. Use theorems about congruency transformations. There's 2 theorems, and we're going to try to hurry up and get to those 2 theorems because you will be confused on them, and we want to make sure we get through them. And it'll be right towards the end of class. Hopefully it'll be right about 2:15 if we get done in time. Write these 3 down. 3 different rules. 3 rules for. Is that yours, Mark?
No. I don't use that type of pen. I use gels.
3 definitions for congruent figures. The first one is the book's definition. I don't like it, so I came up with two other ones. Before somebody gets down there, probably Tyler. Before he gets down to that second one, he says, you spelled if wrong. Somebody tell him again, what's that IFF?
If and only if.
If and only if, very good. Means if and only if.
All fucking smart.
The first one says, two figures are congruent if and only if there is a rigid motion that maps one figure onto the other. So if I have these two triangles, what might I have to do to get them to map onto each other? Make up something. There's not really a wrong answer here.
Rotation.
Rotate it around. If I rotate it around, might they match up?
Sure.
Yeah.
Sure.
Now how much of a rotation did I have to do?
180.
180. You need to be able to do that. That's part of what we're going to
Two
do.
reflections.
All right. You could maybe do two reflections. Do this. Oops. Reflect it. How, Mark? This way?
Reflect it through the center of that one.
That way?
Over the line.
Maybe
Over
maybe
one
this
middle.
way, and then reflect it over that way. All right, and that's part of what you're gonna have to do. How would I get these two to match up? Okay, there's got to be a dilation involved there because one's bigger than the other, right? So it can't. They can't match up with what we know right now because we haven't done dilations yet. We'll do that next time. Two figures are congruent if and only if the corresponding angles are congruent, the corresponding sides are congruent. So I match up these two shapes right here. And Daniel can tell me what about these two angles. If they match up, then what do we know about them? They're congruent to each other. They got to be the same. What do we know about the bottom of this shape and the bottom of this shape? They got to be the same. So if I told you the blue shape over here had this bottom side that was 12, then the yellow one's got to be 12. The one I like the most because it's the easiest. What has to be true about these two for them to be congruent? They got to be the same size, same shape. So when I'm looking at these two, why are they not congruent?
Yeah, the same size.
They're not the same size. They're the same shape, not the same size. Does anybody know what these two figures are called instead of congruent?
Similar finger.
Very good. Similar. Similar, and that's what we're going to do like next chapter. We're actually going to do some of it next class, but next chapter or chapter after that will be a whole bunch of
Why
it.
divide it between similar and congruent? You just put it the same unit.
Because congruent means something different than similar.
Congruent means the same.
You should be able to identify congruent.
Congruent means same measure.
Congruent means same, well, for figures it means same shape and same size. So what's similar going to mean when we get to that?
They look like they look the same, but they're not the same size.
Same shape, but maybe different sizes.
So
Alright.
if they're congruent, they are similar.
If they're congruent, they are still similar, but if they're similar, they don't have to be
What do you take?
congruent to each
So it's
other.
kind of like that square thing on this way.
Those things are simple.
Alright, looking at this. Somebody, what do we notice about all three of these triangles? They're all congruent. Tell me what I would have to do to this. Explain to me.
Dilated.
You turn it.
Turn it how?
Oh, you're right.
Maybe 90 degrees counterclockwise. Would that get them to match up? That's what you're going to have to do on the homework. You're going to have to say, okay, how do I go from here to there and be able to explain it out?
90 degrees.
All right? How would you get from here to there? Rotate. How much you think? Maybe 180, maybe 270. You might have to look at it sort of close, right? Rotations are probably the hardest ones to picture in your mind.
Yeah.
All right? Why are these two shapes not congruent?
They're similar, but they're not the same size.
Different, not different colors.
They're different sizes.
Different sizes. All right, write this down. A congruency transformation. All congruency transformation means the same thing as a rigid motion. So how do you move a shape to to get it to match up to another one without actually changing the shape. That's why we're not doing dilations yet, because is a dilation going to be a rigid motion? No, it's going to change the shape. We want them to match up exactly with each other. Fly my camera right over there at you. I scared my kids. Mark's impressed, aren't you? I made that.
It's really decent for what you do.
Jeez.
Man. I thought he was about to roast you.
That was pretty nice.
That was pretty
Then
nice.
your dog
It's
is-
a lot better than the wooden one because the wooden one
Oh, now
is
it's dog
not
with the wooden
practical for what you need to use it for.
So that-
No, this one's pretty good. My son
Could you do
did
any
this
better
one, so.
yourself, Mark?
Mark says I could do better.
I did not say that.
You're thinking it.
They're both.
What would we have to do to this blue one to get it to match up perfectly to that red one?
Slide it.
Slide it,
They gotta
Reflect.
turn it.
Reflect it.
reflect it,
Flavors some diet.
Rotation.
rotate it.
Slide.
If we,
No,
if we rotate it,
Yes.
is it gonna work? Rotate it how much?
180.
180 degrees about
About, yeah.
point P,
About point P.
clockwise or counterclockwise?
Doesn't matter.
Doesn't matter, either way it's gonna get us to the same spot, right? That's what you gotta be able to do. Now, a lot of them on the homework won't just be one easy thing like that. Alright, it's gonna be 2 or 3. This shape might be way over here somewhere. And you gotta say, okay, I'm gonna rotate it, then I'm gonna reflect it, or I'm gonna rotate it, then I'm gonna slide it. Let's look at this one. When you're looking at an example like this, watch closely on this one. This is gonna make a whole lot of difference for the rest of the year on a bunch of stuff. First of all, what's the word maps tell us? Moves it. That's all it means, just moves. So we want to move this black shape so that it matches up to that red shape. What moves do we have to make? That's what it's asking. Now when you look at these names, angle J in the black shape, this angle right here,
That's like one.
it's got to match up with what angle in the red one? Does everybody understand that? You look right here at the names and it's going to tell you. Segment KL. If I told you segment KL was 4 units long, what other segment do you know has to be 4 units long? Segment, say it again, PN. That one there, NP. I didn't know which, I couldn't tell if you were saying M or N. So that one. They gotta match up that way. Anytime you're saying things are congruent or things are similar, you have to match them up a certain way. So somebody tell me, what would we do to this to get them to match up?
Reflect over X. Yeah, X equals.
Reflect over X equals Y,
Or yeah, or Y.
Y equals X. This line right here,
No, reflect over X.
reflect over the X axis.
No. Over the Y.
Y equals X, so Colton's saying reflect over that line. Might that work? To make sure, we'd have to look up what? The rule for that, right? I don't want to look up the rule for that. I'm too lazy. So, what else could we do?
Rotate. 100.
Rotate 180 degrees. What would we have to do for that?
Clockwise over the
Okay, so what would we have to look up for that? The rule again, right? Could we do it without looking up the rule?
Well, yeah.
What'd you start to say, Teresa?
If you reflect it, well, if you reflect it over it that way, it's not gonna line up with
Over which way?
X and then Y.
the X, the Y-X thing.
The y-axis?
No.
So how far is J from the y-axis? So if we reflect over here, it's going to end up there?
No, that's not what I'm talking about.
But you could do
The
that.
line he was talking about goes back.
Oh, if you do it over this, it's not going to match up?
I don't think so.
Reflect it over a Y
Yes,
axis and
I
translate.
think she's right. If we reflect it over y equals x, is it going to match up?
No.
No, because look how far J is. J's only that far from it. What's J supposed to match up to in the other one? M.
And if you
Is that gonna be the same distance?
And if you rotate it 180, it won't match up either.
Rotating at 180 won't match up? Let's look at 180 real quick. Somebody tell me the rule for rotating 180.
That wasn't my fault. My leg hit it and it fell off.
Somebody tell me the rule for 180. Just slide it up here.
AB
Alright.
is to
Negative A, negative B. So watch. Shh. This should be, when we do this, that should be the coordinates of M, right? So the opposite of that would be 1. Opposite of that would be negative 2. 1, negative 2. Did that give us M? No, it gave us P. Is that going to match up correctly then?
Use 2 of them.
So we have to do 2, don't we? So the rotation didn't work. So what, tell me where to go then.
Reflect it over the X.
Reflect it over the y-axis.
Which one, X or Y?
Y.
Y? We already did, I'm gonna do Y just because we already did J, right? 1, 2, 3, 4, 1, 2, 3, 4. That's gonna be L prime. That's J prime.
That can't, you have to.
You can't do
One,
it, you have to
two,
do it over
Get
the
the
X.
translate and
Do
then.
it over
One,
the
two,
X.
three.
You have
That's
to
K
translate.
prime.
No, you have to translate then reflect.
Oh, that's not gonna work either?
No, you have to translate the reflect to reflect to translate.
How come that won't work?
Because you have to translate, because the K.
It can work. Yeah, it can work.
Over X and then
No, it can't, because then the K is on.
You have to
It will-
reflect
Flip it over X instead?
Flip it over X.
So here,
It doesn't matter.
J prime's gonna be there.
And then translate.
4,
Translate
K
that.
prime's gonna be here. That's K prime, that's J prime. L prime is here.
And then just
And then
slide it.
translate.
Now, so if I could draw, my pen's way off. It's supposed to be up here, right? So our first thing is, what do we do?
You reflect
Reflect over, I'm sorry, not over, reflect
this
in what?
in
X-axis, that's our first part. This is what you're gonna have to write on your homework. That's the first thing. Then what?
Translate it.
And then.
So we're gonna slide it. Now, when you write a slide,
X plus
we don't want the little 4th grade thing. Alright, I know that's what Daniel wants to do, is a little 4th grade thing where you say, you slide it 6 to the right.
Translate
Or you
X
s-
plus 5.
You gotta write it as the rule. Write it as the rule. XY goes to,
X plus 5.
what do we gotta do to get J prime to match up with M prime
Have
there?
to end.
5. So how do I write that? Colton
X
said it.
plus 5.
X plus 5. What's the Y gonna be? Is it gonna change? So we just put Y there. That's our answer. That's our congruency transformation. We gotta hurry up, Michael's gonna die.
I seriously did not mean to do that. No, I like.
Write this down, draw that picture. This is the hard stuff. So as bored and tired as Michael is, he's gonna stay up for these next 2 slides, next 3 slides, sorry, right?
Depends on how long it is. Yeah. I'll do my best.
Because otherwise he's gonna be lost.
Those ones you want us to pay attention on?
Yes.
Then yeah.
Quentin's going, pay attention all the time. I know that's what's going through your head. See, I can read minds.
I was thinking more like he's walking.
How bad was your one to affect my grade? If it's like a 94 right now.
Probably take it down to like a 52.
You just done.
It's hard to straight.
See what I did there? I
already
actually-
thought about it twice.
I actually made up a number that he would have to think.
Twice about it.
See, if I would have just said 30 or something, he would. Nah.
Doesn't sound right.
But
Right.
you should have taken longer than that one. 55.9.
I don't know, but I'm going to Chipotle in about 30 minutes.
It's Chipotle.
All right, on this, what this is saying. In my last class, they figured this out. I hadn't had anybody else figure it out. If I have this segment here, and I reflect it over, first of all, what's these two arrows tell us?
They're parallel.
Those are parallel. So if I reflect this over this line M, what's it going to look like? Somebody come up here.
Exact same.
Somebody come up here and take the ruler out of my hand and show me what it's going to look like over there.
It would be,
Look, come show me. Watch, because I think you're going to be able to make fun of Colton here. He's always making fun of all the rest of you. Oh, wow, he knew it. Does everybody agree with that?
I can't even see it.
I do that at like
I got it.
5:45.
Yeah.
All right? Now, where's it going to be if you reflect it across the other one?
Gonna change, yeah.
It's going to go back
To its original shape.
like that, right?
Yeah.
Yeah.
Now, what this theorem is saying, if you start here and you reflect it into here, then you reflect it over to here, isn't it the same as doing what? Just sliding it to there.
True.
So they're saying, instead of doing two reflections over a pair of parallel lines, an easier thing would be just to do one translation over both of them. That's what this theorem says. Alright? See, you can see my talented PowerPoint work here.
you put so many.
Sure
Put it all together.
Oh my god.
It must have taken forever to make it.
So it looks like that, right? Now what could we have done? Just slid it right over there, went green one to the purple one or whatever color that is.
Sure.
Right? Now, what that's going to help us with, what if I connected A to A double prime, if I could draw?
Be a straight line.
It's going to be straight. Is it going to go through A prime? Yeah. What's going to be true about this angle right here?
Every line.
Because it'd be 180.
It's going to be
So no, it's gonna be
90. What about this angle right here? 90.
And then they equal.
It's good.
Now, this is what we're saying here. This is what you're going to use this for. There's two rules that go along with this picture. Write down these two rules.
We had to draw the picture.
Now, you don't have to draw the picture again. You already got it on there, right?
No.
Oh, you should have drawn the original picture there. Yeah, I did. I said draw the picture too. I didn't say I wasn't listening. Don't say I didn't say so.
Oh, I had to draw a picture.
You were supposed to.
I didn't.
He's just
I
gonna-
really didn't hear
No,
much
we shouldn't do
of
that. That makes sense.
Oh, I
I
was
feel like
supposed to
it's-
stay away.
He did. That changed on us.
Do we ask you?
We don't You just got told.
You should be used
Thank you,
to it.
Trina.
Everywhere to draw, just draw.
You should remember,
How many more slides do we have?
2.
Michael's counting down.
he's counting
I don't
till
mean to
Mark
pull
gets
a Michael
to
here, but like, can I go to the bathroom after?
What's that? There's that.
You're always having to
You're
go to the
always
bathroom.
Yeah. that's
Lane,
true.
you probably don't want to get in on that conversation.
I have
You
here.
go
We're
We're going for like 40 minutes.
You go
Hey,
a
so-
lot. You go a lot of places.
Like, hold on, one
Is that
second.
good or bad?
You can take
Oh, I'm writing it, it's written down. Oh, wait, oh, no, you changed it, okay.
Have a bathroom pass going to the cornfield.
He's a cornfield.
He's a cornfield light on.
Very corn fed after it.
Somebody read this to me. What's this say?
A double prime.
Line.
Line.
Segment.
Segment.
Prime,
I don't know.
A, double prime.
All right, sort of hard to say, right? Segment A double prime. What they're saying there is if I connect A to A double prime, like I just said,
That's a beautiful.
what's going to happen to, or what's going to be true about this angle right here where it connects to this parallel line? It's going to be a right angle. How about this one over here? Right angle. So it's going to be perpendicular to that. The other thing it tells us, if I told you this distance right here from this parallel line to this parallel line was 20, this tells us that that distance is called D. And the distance from here to there should be what in relationship to that? So how long is it from A to A double prime? Should be 40. Should be double that. What if I told you the distance from A to A double prime was 100? Then this distance down here should be 50 between the two parallel lines. It's not really hard, it's just confusing. All right? One more. Write this down. Yep. You might try to draw the picture. You don't really have to draw a lightning bolt like that. You might just make a
Yeah, listen.
something like that or something. I don't know. This one's a little tougher. It's a little tougher to understand.
And very long.
I would doubt
Don't
that
make fun of him.
writes
Quit
an entire book
because he's whining.
on theorem 4.3.
I have no idea
because
what
it's
anybody's
that
saying.
long.
But
I'm literally blocking everybody out.
Stop talking.
Why, Dakota, you want me to make fun of you? If I was going to make fun of you, it'd probably be your hair.
that's what I was gonna say.
Looks like the top of a blue Tootsie Pop.
You look like a short.
What?
You look like a Sharpie.
That's a pretty good one.
Shady said that looks like a Kool-Aid packet.
Oh yeah.
Oh,
You should be like,
I
what
just
you
realized
say,
that's
Johnny
so
Bravo? I heard that's what makes him
I didn't get it.
I heard if you call him Johnny Bravo, that'll make him really mad.
Who, Shady?
Yeah.
He looks at me and said, every time
Does it- does it?
I don't know. That's pretty funny.
I get into it. Every time I look by
I
him, he
heard
goes,
someone
go get
else
him.
got
Hey,
suspended for
he
calling
says,
Johnny Bravo.
hey, Lane, there's Taliban over there. Go get him. I'm like,
He was making fun
He
of Wade
compares me to
Nugent
my
one day because Wade was talking about ISIS and the Illuminati, and Shady was just going off. It was the funniest thing.
he went off on him.
Call him, yeah, call him Rusty.
I bet I can. He was probably going, yeah, Wade's going to go home and get in his truck and get in the cornfield and get his gun. Or saying something like that, probably, wasn't he?
No.
He wouldn't say none of that.
No. It was very mad.
He used to call me Mick Jagger.
They called me a little dead.
When you got mad at us.
He literally walks by me and says, Taliban.
You know why, right?
Huh?
Oh, I'll tell you after class. I don't get in trouble for it.
Why?
No, he ain't going to tell you.
Say it.
He'll tell
I'm
you
pretty
after
sure
class.
because I used,
Tell you in the
I used to
corner.
always get an oatmeal cream pie before class, and you used to always yell at me.
When he got mad at us and started yelling at us, I said, oh, chain got rusty. And then he heard me and got mad.
Boom.
I didn't hear it.
So on this, if the two lines intersect, they're not parallel to each other anymore. So if these two lines intersect, and we want to take this shape and we want to reflect it, it's going to end up in here somewhere when we reflect it over that first line, right? And I did some of my fancy stuff here again. So we're going to reflect it over that, okay? And it's going to end up, and it'll look something about like that. Does that seem sensible? Does that look like about where it should be? Now, if we reflect it over the other line, which mine isn't in a very good spot, if we reflect it over that other line, it's going to look something about like that. All right? It should actually be a little farther that way. It's about it's in about the right spot now. Be careful because we're reflecting. Don't go by this line.
Oh, were you doing X
We're
on?
going over this line, right?
I know, but then wouldn't it be?
No, because see, you're looking at
Be
this.
higher up then.
No, the bottom should be about level right across through there. But it should be farther out because look how far this one is from there and that is from there. So it should be kicked out a little farther that way because it should be farther away. Now, what this theorem says is if this angle between these two lines right here is 70 degrees, then instead of doing all that we just did, we could have took this lightning bolt and just rotated it. And would it match up to that green one over there if we just rotated it? Yeah, how much would we rotate it? And that's what this tells us. We'd rotate it 2 times x. Well, they're saying x is 70, so how much would we have to rotate it?
Something.
A little bit. 140.
140 times by 2. Focus. So we rotate it around there, and we should be able to rotate it 140 degrees counterclockwise, and it would end up in the same spot. Now, when you guys that were just messing around there come in here and say, well, I don't understand this problem, we'll say it's because you weren't listening right then.
I was messing around and I don't understand that.
So do you want me to go back over
Yes,
it?
I do.
And everybody's going to listen this time.
I was.
Yes, sir.
So, if we reflect it over this line, it's going to go from the blue one to where the purple one is.
Yeah.
Then we reflect the purple one over this line. It's going to go to where the green one is. What this theorem is saying is that instead of doing all that, we could have taken this and rotated it, and it would end up in the same spot.
Yeah.
Now, we got to know how much to rotate it. And a way we figure out how much to rotate it is this angle right here, which is our x. We double it. So how much do we rotate it?
2.
140 degrees.
That's not what I meant, 2.
I'm watching the video here.
I meant like 1, 2.
Cool. Hey, you were right. It is 250.
I hope you